Hey, what's going on, guys? So this is the engineering methods once again. We continue with the tutorials for kinetics of particles, and so in this video we will be specifically looking at kinetics of particles, impulse, and momentum. So our question goes like a block A, which is initially at rest, is acted upon forces P as shown. If the mass of the block is 50 kg and the coefficient of friction between the block and plane is 0.2, find the velocity of A when A time is 3 seconds. So we are to determine the velocity of block A when time is, of course, 3 seconds. And in this example, for the remaining 2 times, it's more like the same thing. So we're gonna solve for A. So because it's basically repetition for the 2 remaining times. So it's a term. So from the question, we have our mass, the mass of block A, which is 50 kg, and we are told that the coefficient of friction is 0.2. So we are asked to find the velocity at time when time is 3 seconds. So we have our free body diagram of block A. So we will have our normal reaction acting this way, and our weight acting this way, which is mg, and friction force acting this direction. This is our friction force. So we are going to first of all determine the friction force acting on block A. So the friction force acting on block A is given by mu times normal force will give us the friction force. So we don't know the normal force, but yet we know that we have mg here. So from the symmetry of the equation, we can see that the resultant force in the y direction is 0. So we will have our normal force being equals to mg, which means the mass of the block A multiplied by 9.8. So that will give us 490.5 Newton, which is our N. So from here our force will be, our friction force will be 0.2, which is the coefficient of kinetic friction, multiplied by the normal reaction force, giving us 98.1 Newton. Remember, this is friction force. So for this box to move, our P should be greater than Fr. For box to move, P should be greater than Fr. So from our diagram here, our graphical representation, we have the value of P being 200, and obviously it is greater than our friction force, which means that the box will move. Now, in order to find the velocity at this time, we are going to use the momentum relation, which is mv minus mv1 is equals to integral of t to t1 summation of p dt. This is our relation. So notice that initially our box here, our box A, it is at rest. So meaning that our V1 will be 0 and this will come to 0. We will have mv2 is equals to t2 t1 sum p dt. Making v2 the subject of the formula, we have our v2 being equals to 1 over m t2 t1 sum of p in the y direction dt. Okay, so this basically means that we are taking the area under graph, from time t0 to time is equals to 3 will be here. So we will have our shape looking something like this. So we are going to take the area under the graph, and notice that this p is a constant. We will take it out of the integral side, and we will have our values being 1 over 50, 200, which is our p. So this is the summation of the area. We're going to take the sum of areas under the graph and add them together because it's a sum, times. So this, from this point to here, we have our length being 200, which is our first p, and our width is 2. So this is 200 times 2 plus, we have this area here, I mean the area of the triangle here. So area of the triangle is half times times 50 times 50 times 1. We have this is the distance here is 1, and notice that this is 100, so the area, so it's not drawn to scale. So we have our, let's say I could have drawn it to scale, so we have 100 here, so, and our 50 here. So our line should be passing from the diagram, should be passing somewhere like here, so giving this the value of 50. Okay, so I'm going to continue, plus 150. So notice that from this point to this point is 150 multiplied by 1. So that will be 150 multiplied by 1. So pressing into my calculator, you get your V2 being 5.6 meters per second. So this is the velocity after the time, after 3 seconds. That is the velocity. So notice that you simply take the sum of areas under the graph. And for the two remaining times, which is TB, the time on B is time T is equals to 6 seconds and 7 seconds. Basically, this is what you do. You repeat the same process and you get your answers. So thanks for watching, and more content coming. Remember, this is the engineering methods, and always remember to smash the subscribe button for more content and give us a thumbs up if you like the video. Thank you.